All right, so yesterday talked about probability distributions, right? Was that pretty straightforward, pretty simple to do? Okay, so determine how many values that the discrete variable can take on, and then we try to determine the ultimately the relative frequency of that particular value, and that will create our distribution. Today what we want to talk about is expected value and standard deviation, okay, of a probability distribution. And really what's going to happen here, so yesterday it was basically setting up that table showing what the distribution looked like, and now once we've got that distribution, we can use that effectively to find what we call the expected mean, okay? And once we have the expected mean, that's going to lead us into standard deviation, which is the ultimate goal, okay? So expected value says it's often referred to as the long-term average or mean, okay? So over the long term of doing an experiment over and over and over, you would expect this average, okay? We can think about it as the theoretical average of a variable that has a probability distribution. If you do some research on expected mean, they basically talk about it being a weighted average, essentially, of a probability distribution, okay? And the idea is we are going to do an experiment over and over and over and over and over again, and we know the probabilities of certain things showing up, certain results showing up. If we do this an infinite number of times, we basically multiply the probability by the random variable, okay, the discrete random variable, and add those together, and it's going to give us our expected mean, okay, which is what we should expect to happen over a long term. Okay, and so the law of large numbers actually allows this to exist. And I think the best way to explain this is think about an insurance policy. Okay, so if I have, does anybody pay for their own insurance, car insurance? All right, so let's say my premium for my car insurance is equal to $100 per month, okay? So in 1 year, my insurance company makes $1,200 off me, right? Okay. So every year, so let's say that I have not had a wreck for, let's say, 10 years. So they would have made $12,000 off me just by my premium, just so that I'm protected in case I do get in a wreck, right? Let's say the first day of my 11th year of my policy, I total my car. Let's say I total my brand new car. Let's say I had a really nice car. Let's say I had a $70,000 car, and I totaled it. What did the insurance company just lose out on me? How much money? In these 10 years, they were positive $12,000, right? Now in 10 years and 1 day, they have now become negative $58,000, right? Does that make sense? Okay. So because I totaled it, so that what that basically means is that they are going to pay to have that replaced, okay? Because I've been paying this premium. Now, obviously, there's other things that go into this because they're not just making $12,000 off of me. If they were to take my $1,200 check every year and just put it strictly into like a savings account or like a coffee can or something like that, that would be a terrible insurance agent or program. But what they normally do is they'll take your policy and then they invest it. So they make not only what you give them, but they're going to make dividends off of the investment. Does that make sense? So if we neglect that that's how that part of the finances work, they lost out $58,000 on me, okay? So was I a good person to have for them to provide insurance for? Collectively not, right? Over 10 years in 1 day, no. For those first 10 years, I was a premier person for them to carry my insurance, okay? Because they were making money off me. But now, think about this. Are there other people that are paying insurance as well? similar policies, if not the same exact policy, right? So not only were they making $12,000 off of me, they were making $12,000 off of somebody else, and then $12,000 off somebody else, right? Okay. So let's say that we have an insurance company that's making, let's say that they have, let's just say 30,000 policies. So if they're making 30,000 policies, and each of them are making a bare minimum of $12,000 off of each one of them over a 10-year period, are all 30,000 policies going to have a $70,000 claim? Is every person going to have of those 30,000 people going to have a car wreck where they total their car? No. Some of those people aren't going to have a wreck at all. They're going to pay for 30 years maybe, or however many years, they're going to pay their insurance every single year and never have to use it, never have a claim. Other people might have a total claim. Some people might have like a $3,000 claim, okay? But a majority of people don't get in accidents, right? A majority of people don't have total claims that happen. So even though they lost money on me, they're making that money up somewhere else off of somebody else that was a better driver. Does that make sense? Okay. So what the insurance company can determine is that there is an expected average, okay, or expected mean that they can realize off of the insurance policies. Okay. And we'll see an example of this. We don't use cars. I think it's a coin collection if you go through the example in the notes, but it's the same idea. You can insure anything, right? Okay, you can insure a lot of like star athletes will insure their hands or their feet and stuff like that because if I get in an accident, like Jean-Pierre Paul, I think that's his name. He was the defensive lineman for the Giants, okay, and he was one of the best defensive linemen in the league at the time. He was out playing with fireworks on July 4th, and he blew his hand off. Okay, so as a defensive lineman, as a defensive end, I need my hands, and then I need to be able to grasp things. So he's got his hands were insured, and so basically what they do is, okay, if I'm like major like violinists and pianists, okay, they need their hands to play their instruments, correct? They will insure their hands. Because once their hands go, maybe they get like rheumatoid arthritis or something like that, or they get in an accident and they lose function in a hand, can't play violin anymore, right? So what they'll do is they'll insure their hands for that lost money in case something happens. So they'll insure their hands for like millions of dollars, something like that. Now the premium, the payment on that will be varying per like what you make and what you're insuring it for, but you can insure anything. Does that make sense? Okay. So the law of large numbers is really what is going to allow us to work with this expected mean. And it says, when we talk about the law of large numbers, this is a little bit different way of defining it than what we've seen in the past. It states that the number of trials in a probability experiment increases. The difference between the theoretical probability, so that's what we think should happen based on mathematical principles, and the relative frequency. Well, the relative frequency, that's another way of saying what was the experimental probability. What was, if I'm flipping a coin and I do it 10 times and I get 7 tails, well, that's 7/10 or 70%, right? Okay, 7 successes out of 10 total trials, so that's the relative frequency. What they're saying is that as we have the theoretical probability and we have our experimental probability, it says the difference between them approaches 0. Well, if I take two numbers and their difference is 0, or very, very close to 0, what does that tell you about those two numbers? They were what to one another? Take two numbers and subtract them and you get 0. What were those two numbers? The same thing, right? So this is another way of saying that your theoretical probability, this is a mathematical way of saying your theoretical probability and your experimental probability are converging. They're becoming the same thing using the law of large numbers. They net out a result of 0. Here it says when evaluating, should say evaluating, not evaluation, but when evaluating the long-term results of statistical experiments, we often want to know the average outcome, okay? What happens in an average situation, okay, overall. So this long-term average is known as the mean or the expected value of the experiment. We are going to denote it by mu. Now, this tells me something, okay? And it's because we're doing this in the long run, forever, maybe an infinite number of times. So this is not a statistic. This is a parameter. This is a value that describes the population. Okay, the expected mean is a parameter. It says after conducting many trials of an experiment, you would expect this average value. Okay, so this, as we see some examples, I think that terminology, those phrases here are going to make a little bit more sense. Some formulas here. It says to find the expected value or long-term average, you multiply each value of the random variable by its probability, and you add the products. Doing this, multiply each value of the random variable by its probability. That right there is how we do a weighted average. Okay, so that's essentially what we're finding here. Now, there's a couple different ways. We call this mu. Okay, it is also capital E of X, which is what we refer to as the expected value. Okay, so there's a couple different ways of notating what we are dealing with here. Okay, E of X is expected value, or we can call it mu. Our textbook uses mu for the most part. And remember what this means. What is that sigma, capital sigma? What does that mean we're going to do? We're going to sum. We're going to add things up. And we're going to add all of our x times p of x. So x, remember, is the value that your random variable can take on. And p of x, then, is the probability of that random variable. So you know how often that occurs. So yesterday we had this scenario where this, I think it was like an industrial psychologist or something like that, interviewed so many people and determined on the aggressive to, or I guess passive to aggressive scale. They gave people that were really passive a 1, they gave people that were really aggressive a 5, and people that were neutral, they gave a 3. If we want to find the expected value of that process, okay, of that research, what we're going to do is we're going to take the probability of a 1 and multiply it by essentially the weight of that variable. So I'm going to take 0.16 and we'll multiply it by 1. Okay. Then we'll take 0.22 and multiply it by that random variable value of 2. And we'll do the same thing for all of these. So 0.28 times 3, 0.20 times 4, and 0.14 times 5. Okay. So that is finding the individual weights essentially for our expected value or our mean of our probability distribution. So adding those up, so we'll have 0.16 plus 0.22 times 2. You don't always have to have, I mean, having the table is nice. And that's what we worked on yesterday, is developing this table for this purpose, being able to come up with this column here. Like I said, it's not always necessary if you can organize your work other ways. All right, so I got 2.94 back. Okay, so what that means, now think about this. If we were just to look at this class and we did this experiment, okay, we're going to have some people that are 1s in there, and we're going to have some people that are 5s in there, right? A 1 and a 5 basically cancel each other out, and you get a 3, correct? Okay. Over the long run, what this is saying, okay, if we take an infinite number of people and we categorize them, okay, as 1, 2, 3, 4, or 5, on average, we are going to have 3. Does that make sense? 3 is going to be the expected value for this particular scenario. Does that make sense to everybody? Okay. Now that is of then, that's a parameter, so it's of the population. Now, I think maybe, and that's fine. Usually what we're going to do is kind of talk about the expected value and link it to standard deviation. So maybe a use of expected value right now in this example might not make a whole lot of sense, but I think it does make sense as we look at maybe situations like this. Okay, so think about gambling. Anybody gamble? You shouldn't tell me that. All right. So we gamble everything, right? Everything's a gamble, right? Came to school today. I was gamble. Get here, right? Yeah, we're always risking things, right? That's what gambling is, right? Yeah. Okay, so if I'm gambling for money, though, let's think about casinos. How does a casino work? What are they? All right, so if you know anybody that is a gambler, they will share stories with you. I have a family member that he gambles all the time, and he'll tell me, James, I made $25,000 over the weekend. And then next weekend he'll tell me I lost $30,000 last weekend, and it blows my mind. Okay, I'm like, you lost $30,000, but the week before he lost $25,000. Next week he'll go make $15,000. Does that kind of make sense? Okay, so he's fluctuating, but as a casino, do casinos ever lose money? Why? Okay, so the way that they structure their payouts, okay, is designed knowing expected averages or expected means, expected values. So let's say that let's say Peyton goes. Let's say we're all gamblers, okay, and we all go to Vegas one evening, and let's say money's no object to us, okay, so we just start playing, okay, and 15 of us suck at gambling, and we all lose our butts, okay? Let's say we all lose $30,000, okay? So the casino made a lot of money off of us, yes? But let's say Peyton wins $10 million, because he seems like he'd be a wise gambler. I'm sorry. So did they lose a lot of money off of him? He just won $10 million, correct? Okay. But the rest of us, we all lost $30,000. So that nets out to something, correct? So the casino may have lost on us as a group, or they might have won a little bit on a group. But now extrapolate that to as many people that go to casinos, and how casinos are open 24/7, right? Every day of the week. Okay, even during a pandemic. Okay, so when they pay out $1 million to somebody or $500,000 to somebody, that's getting recouped by them, because now they've got, in the other parts of the casino and other games, they've got hundreds of people losing money to them, paying them money. Does that make sense? So they know their games are structured, and they structure their payouts so that they always make a little bit of money on average for everybody, even though you might specifically be a person that goes in there one day and loses $50,000, or you might go in one day and win $10 million. Overall, in the long term, in the long run, with all the people that gamble, they're going to make money per each person. Yes? So, how do the big sports, how do they make money? Because they can't, they're not in control of the players. Right, but they have enough knowledge about, and to be honest with you, I don't know what all dynamics go into making a betting line and all that kind of stuff, but it's statistical. And if you think about how they do it, they start with a wide gap, so they get a lot of money to come in, right? Or they make a lucrative bet, and then through the week it kind of starts to shift and change. And some of those times that when they shift and change will be maybe a star quarterback gets hurt, okay, and then the odds change a little bit, but it's all based off of knowing expected means and expected averages. Now, there's a whole lot more mathematics. I mean, those people that set that stuff up, they're one, they're pretty good mathematicians, but two, they know their field extremely well. They know, baseball or basketball or football extremely well. Yes. I know. I was going to get to her, but you were in my line of sight. Brooklyn. Oh, yeah, there you go. So suppose you play a game of, so this is a gambling situation, okay? So this is taking the casino idea and narrowing it down to one situation, but you maybe see the casino and how complex that casino situation can be by just looking at one specific game. So suppose you play a game of chance in which 5 numbers are chosen from 0, 1, 2, 3, all the way to 9. Okay, it says a computer randomly selects 5 numbers from 0 to 9 with replacement. Okay, so a winning number could be 0, 0, 0, 0, 0. Okay, you could have all 1s, you could have all 2s, you could have all 9s, whatever. Okay, it says you pay $2 to play, and you could win $100,000 if you match all 5 numbers in order. Okay, it says over the long term, what is your expected profit for playing the game? Okay, so I might play this game one time and not win. I lost $2. And the average would have been I lost $2, right? I could play it 2 times, and I could lose both times. I lost a total of $4 per playing twice, so -4 divided by 2 would be -$2, right? And I could keep doing that. Maybe I do it 10 times, and I lost $20. But on average, I lost $2 per game, right? Okay, and I could do this forever, but if I keep playing this game over and over and over again, the law of large numbers says you are going to win eventually. Does that make sense? Let's talk about, okay, so if I have all these losses and I've got then this one win, what can I expect to have essentially lost or gained per every game I played? Okay, so that's what an expected value is talking about. So you pay $2 to play, you're going to win $100,000. So if you match all 5 numbers in order. Okay. Now, when it says that you're going to and this is just a little like caveat of this type of problem. It's not a huge deal. If I were to give you a question like this on your homework or not your homework, but your test or quiz, and you didn't abide by this, I'm not going to mark anything wrong. But it says if you win, you get a profit of $100,000. Okay, that's what you win, and you get your money back. So we're net. I just want to make sure that some people will say, well, you paid $2, you made this, so you really only profited $99,998, right? The idea here is that you're getting your $2 back, so you're starting from square one. Plus, then you get your $100,000 back, so you profited $100,000. Huh? But I have to pay $2. So think about so right now currently, I might have $2. I got $15. That's the most money I've had in my wallet in about 36 years. All right, so let's say these are dollars. Okay, so, So if we're gonna play this game, so I gotta pay you $2 just so that I can guess, right? Okay, so how much money am I down? I'm down $2. Okay, if I win, I get my $2 back. So where am I at? 0, and I make the $100,000. So what did I profit? Yeah. If you win, you get $2 back and your $100,000. Hence the word profit. Okay. Wants us to construct a probability distribution for this, and when we do that, we have to decide. Okay, well, when we gamble, there is a very, 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 very small chance of winning, and a very, 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 very large chance of losing. Correct? That's usually how gambling works. If I'm going to profit, and I got typo down here in the notes, this should be. So my random variable is going to be the profit, the amount of money that I profit, okay? And that could end up being $100,000, Okay? Or my random variable could take on the profit of -2, right? That would be a loss. So now we got to know what is the probability that goes with those. So this is where some of the stuff that we talked about in the last chapter, why that chapter came first. If I want to know this situation, okay, does the fact that, I guessed a number to be like 3 on the first choice, does that impact whether the next number is going to be 5? And it doesn't, because it says with replacement, right? So if it's with replacement, what kind of events are these? Independent. Okay? So if they're independent events, then it means that all I've got to do to figure out the probability of winning, the probability of guessing these 5 numbers, is the first number is a 1 out of 10 chance, right? The second number is a 1 out of 10 chance. Third number, 1 out of 10, 1 out of 10, and the fifth one is 1 out of 10. Well, that turns out to be 1 out of 10 to the fifth, right? 1 out of 10,000, or sorry, 100,000. 5 zeros, correct? 4, 5. Okay, that's the probability that should be right here. So it'd be 1 out of 100,000. Is that okay with everybody? So now, how do I lose? There's a couple different ways you could do this. If I lose, then it's 9 out of 10 right there, right? Does that make sense? If there's one value, so let's say if 3 goes there, then I lose if a number other than 3 goes there. Same thing here, all the way through. Okay? So what is a better way of doing that? And this is essentially, and we'll talk about this later on in the next section, this is a binomial distribution because there's 2 results that could happen. You could either win or you could lose, right? Okay? Are those complement events? If I tell you I've played 20 games and I've won 3 of them, do you know how many I lost? Does that make sense? So if I win this percent of the time, don't I lose 1 minus that? And that's what we're seeing here. Okay? So I'm going to type these or write these values in here. We'll use Desmos to demonstrate what should go here. But you're going to take 100,000 times 1 over 100,000. So, I mean, that one's kind of easy. What's 100,000 times 1 over 100,000? 1, right? The reciprocals. So now -2 times that number, that's the one we probably can't do in our head. So let's see here. So we had 1 minus 1 over 10 to the 5th. Okay. And now I'm going to take -2 times that. So -2 times that would give me that, right? So that's what, 4 9s and an 8? So -1.123 and an 8. I don't know. So remember what expected mean is. Expected mean, or expected value, E of x. That is also mu, which was the sum of those 2 things. If I add those 2 things together, what do I get? This one's negative. -0.99998, right? Okay. So that's pretty close to -1, right? So what this means is if you are a person that is going to play this game over and over and over and over and over again an infinite number of times, you can expect to lose $1 per each game. Does that make sense? So if this was a casino game, the casino, the individuals are losing $1. What's the casino making? They're making $1 off of every time somebody plays this game. Okay? Even if I go in and I play it one time and I win it the first time. Okay? I might win it the first time and I won $100,000. They lost $100,000 on me. But they're making $1 off of everybody else. If let's say everybody else plays 100,000 times, they've made $1 off of them 100,000 times, and they lost $100,000 off of me one time, so they're at net zero now. Does that make sense? But more people are going to play this, okay, than what people win. So they're going to net $1, and I can expect to lose $1. Does that make sense? So let's talk about how this works we'll skip this next one with cards. This is another one. So sometimes because we get to the point where, flipping a coin gets kind of boring with one half all the time, right? So what they'll do is they'll tell you you have an unfair or a biased coin. Maybe one side's made out of a heavier metal than the other. So we find out that heads shows up 2/3 of the time and tails shows up 1/3 of the time. Okay? So we've got this game that says you play each game by tossing the coin once. If it lands heads, you pay $6. If it lands tails, I win $10. And it wants to know what is the expected value if you play this game over and over and over again. Okay? So I win 1/3 of the time. So it's getting a tails, right? So you win 1/3 of the time. You win one. That's the probability, 1/3. You lose 2/3 of the time, right? Now, what are the numbers that the random variable can take on? Which the random variable is the amount of profit. What do you get when you win? $10. What do you get when you lose? -6. Now, there's nothing that I don't pay out here to play the game, right? Okay, so Lucas is on the street, and I walk up. He's doing some street gambling. I walk up to him. He says, "Play this game." But once you agree to play, you have to pay if you lose. I have to pay you if you win. Does that make sense? Okay, but there's no buy-in to start the game. So there's nothing with that $2 in the last question where we had to worry about that with the profit and all that kind of stuff. Okay. So if I want to then find the expected value, it's X times P of X. So here, X times P of X is going to give me 10/3, right? Here, X times 2/3 is going to give me -12/3. If I add up all of those X times PX's, what do I get? -2/3, right? Which is negative, I'll round it to the nearest cent, -0.67, right? So I play this game over and over and over again. I can assume to lose in each trial, each time I play the game, to lose on average 67 cents. Lucas, if he's running this game, he's going to make 67 cents, right? Okay. So gambling games, carnival games, you go to the fair, okay, all those things are skewed so on purpose so that in the long run, the carny always wins. Why? All right, so we do the same thing with insurance. So insurance is basically, they're taking a gamble essentially on writing somebody a policy. Okay. So here it says an insurance company insures a person's antique coin collection worth $20,000. Okay, for an annual premium of $300. It says if the company determines the probability of the collection being stolen is 0.002, what will be the company's expected profit? So when you sign up for insurance, I just had to do this the other day. Okay, so every November our insurance window opens up and I can change things in it. Okay, I can change my policy, all that kind of stuff. So I have insurance in case my wife dies, and she has insurance in case I die. I actually have insurance in case I die that she'll get money. Does that make sense? Okay, so I've tried to increase her insurance. Okay, and in case she were to pass away, try to increase that so that my girls are better off if she's not around. Well, they wouldn't be better off if she's not around, but they would have money if she's not around. Does that make sense? Okay, hold on. So I have a lot of trouble doing that. My wife, we can't, and she herself, when she tries to put insurance on herself in case she passes away, so that the family will be able to claim that. Because when she was in college, she got an autoimmune disease, which is very rare, and she like took chemo and all that kind of stuff, and because she has a pre-existing condition, essentially, they're saying she is more likely for us to have a claim on her. Does that make sense? So she's more likely to pass away than Mr. Fay is, because I don't have that autoimmune disease. So getting an insurance for her is so they decline her a lot. Does that make sense? Because the probability is much higher than the coin loss that you have 0.002. Okay, but they know through previous situations, they know these probabilities of being like 0.002 from past experience. Yes?
There are two life insurance policies on me. In your professional opinion, do you think my mother's trying to kill me?
No. I have several life insurance policies on both my daughters. Because so what, I mean, it's morbid and it's terrible, but like if a child dies, funeral costs are like $10,000 to $15,000. So that's out of pocket if you don't have an insurance. So this one says an insurance company insures a person's antique coin collection worth $20,000 for a premium of $3,000 or $300. If the company determines the probability of the collection being stolen is 0.02, what's the probability that the company's expected profit? So we have two situations, okay? There could be a claim or no claim, right? Okay, or a stolen, not stolen. My X value, my random variable, can take on two values, okay? And I'm the insurance company right now. We're setting this up as the insurance company. So the insurance company, okay, if there is a claim, they're losing $20,000, right? No claim, they're making $300. Those are the two values that that our discrete variable can take on. What is the probability of a claim? You're only going to claim it if you lose it, right? So 0.002. So what's the probability of not a claim? 0.998. Okay. Now, like I said, insurance companies, they'll have a threshold, and there's a lot of analyses that they go through. They might have a threshold say, if it's 0.05 or greater, we don't claim it or we won't insure it. Let's say that we go back to that question where that football player was playing with fireworks. Okay. Well, if he owns a fireworks business, they're probably not going to insure his hands. Does that make sense? Because he's more likely to have, if he owns the business, have an accident with that stuff. So now if I go X times P of X, okay, so we're going to multiply those out. So we'll just grab Desmos here real quick to let us do that. So a lot of times when I create my charts, I don't fill them in completely because I'm going to grab Desmos to do it for me anyways, but I know I'm going to take negative 20,000 times 0.002 and then add to that 300 times 0.998. Okay, and we get 259.4. So the expected value is 259.4. Okay, meaning, okay, if we have coin collection after coin collection after coin collection after coin collection insured underneath this company, they are making $259.4 off of every single policy. Does that make sense? And it's because some policies they're going to make $300 off of in a year, but some policies they're going to lose $20,000 a year. Okay, but the ones that they make $300 off, there's a whole lot more of those than there are losses because of the probabilities that are there. Does that kind of make sense? What expected value is? Okay, so tomorrow, bring your computer. Make sure your computers are charged, and we're going to run through a quick. Just make sure. I know some people have never been on Schoology, and there's more and more. I keep getting emails about we're not going to a hybrid model, but here is what would happen if we were to go to hybrid. So I want to make sure that we run through some scenarios on and places that you can find information on Schoology if you've never been on it before. So bring those tomorrow. We'll do that quickly. No quiz or anything tomorrow. There is a homework assignment open for these expected means, and there's going to be some standard deviation stuff that we get into a little bit tomorrow as well. So you can't finish that assignment yet. Monday will be the exam. I sent that out yesterday to you, the practice to you yesterday. I just finished up critiquing the actual one. Extremely similar, still 8 questions. I think that's it. And that'll be Monday. I also said that I'd open up a take-home portion of that. Will be open all the way through next week into the following Monday. So just a reminder for those things.